Right. So it is February in the year 2021. This is our 32nd Hex 20 meeting. And welcome everyone. And we're looking forward for great talks, and we'll see how this all going on. So welcome everyone. And let me share my screen so we can have a look at the up-to-date schedule. I hope you can see it. And our first speaker today will be Jason Tay, and he will talk about ESP32Forth and how to port it to the M5 stack. And so I stop sharing. So Jason, you can take the screen and go ahead. And then the stage is yours. So.
Okay, thank you. Right, let's get the show on the road. I've also got a double camera set up here, which hopefully will work. I tried it earlier on. So I will share my screen. Okay. All right, so I thought it instructive to also take an application, an example application on which to base it. Otherwise, you know, if you're talking about porting ESP32Forth to M5 stack or something like that, it can be, I don't know, maybe a little bit dry as gin, perhaps. But in my day work, I work in a distillery in Malaysia. A bit unusual, I suppose, because it's a Muslim country. But we have the British colonial powers to thank for that. They gave us a license back in 1908, and we still have it today. And it's a noble duty to continue the tradition, right? So the basic idea is here that I wanted to choose as an application was what is gin, right? So fundamentally, you start with neutral spirits. In general, that means that you have a sugar wash that is fermented and then distilled into a relatively high proof spirit. And then you have botanicals, right? It tends to be juniper berries if it's a strict traditional gin, but you know, nowadays you get all sorts of things. Can be strawberries, can be star anise and various other spices and so on. And then you distill the botanicals together with the neutral spirit, and that gives you gin, right? So that leads us on to, okay, how are we going to achieve this with port? So the approach that I'm going to use is I'm going to use a fairly commonly available water distiller, right? You can see this device right in the center here, the white appliance. It's basically, it's very much a rice cooker, basically, with a fan-driven condenser on the top. The reason why I say it's basically a rice cooker is because it is a stainless steel pot with a heater welded to it, and it has a 100-degree cutoff. So if you run out of liquid inside the pot, the switch will automatically disconnect the heater if it rises above 100 degrees, exactly like a rice cooker. And we're going to add an M5 stack to it in order to act as the controller. Why the M5 stack? Because, well, we're going to see in a minute that it has a lot of things going for it. Now, it has to be said that in effect, I suppose this water distiller is not necessarily the best way to distill spirits because it's designed to boil water, right? And if you remember your chemistry, ethanol actually boils at 78 degrees. So if you let it do its thing, it's going to give you too much water. And that's where ESP32Forth is going to come in and help us, right? And what we're going to do is that we're going to control the heating temperature so that we don't exceed something like 85 degrees. Right? So I used an M5 stack and I added on a thermocouple board. It can, temperatures involved, as you've heard, are not very high. And as a result of that, I needed actually to enable SPI. If you notice in the default ESP32Forth source code, that strangely speaking, the SPI interface is not exposed as words in the Forth dictionary. There are some existing projects in the ESP32Forth website that use SPI, but they all use Forth to bitbang SPI out through GPIOs. I just wanted to, to have as much of the hardware supported through a thin API to expose them as words, rather than using up interpreter cycles with bitbang. And then finally, we need a relay to control power to the heater. Now the relay is gonna, obviously it's like pretty much the relay is sits on a GPIO. You can think of it as an LED, a very slow LED, because as we'll find out, we can't blink this LED very quickly. And there are multiple ways to get that done, either through what they call bang bang control of the temperature, or else PID. But the emphasis today is we're going to go through what it took to add M5 stack support to it. It's probably worth going through a little bit about the M5 stack. The fundamental thing you need to know about it is that when it comes down to it, it's an ESP32 in very nice clothing, basically. It does come in at about $50 to $60. From some quarters that can sound a little bit expensive, but at the same time, for example, like my case, at the end of the day, I want to have something that looks quite presentable, doesn't have me trying to make a casing and display and mount the display and add buttons and everything to it. This is actually quite a fast and way to get quite a professional result. If you run ESP32Forth and compile it from the Arduino IDE and run it directly, it will work. It will work like as with any other ESP32 board, except the display and all that won't work. So that's what the support for for M5 stack will be looking to add in today. Okay. Now, in fact, as announced previously a few months ago, this work has been ongoing, and I've been adding to it over the last few months, and it's getting more and more complete. You can find it on the ESP32Forth -org GitHub repository. I've actually got two versions of the M5 stack support there. There was one where I actually had a go at using M5 stack, ESP32Forth directly on the M5 stack as if it were a standalone device, because I do have a QWERTY keyboard for it. So if you can imagine a completely portable battery-powered ESP32Forth hosted locally, but that's not what we're doing here today. Here we're going to use the M5 stack as an end-use application and user interface, right? So all the files that you'll need are actually uploaded already as far as M5's stack support, as well as a number of different examples, including the thermistor example, and thermistor. Okay, so thermistor, I should be adding the thermocouple as well. There are detailed instructions, detailed explanations on all the words that have been added through the user words file, and that gets us to how you install it. So everything has been implemented as essentially a thin wrapper for the M5 Stack API. If you've gone through adding how words are added to the ESP32.4 dictionary, you will find this all very familiar. And if you see on the right-hand side of the screen here, you will see that we're basically adding user words. In order for this to compile, you will have to make sure that you add in the board platform support for M5 stack. And then if you see at the bottom on the status line of the Arduino screenshot, you'll see that you have to select the M5 stack core has been selected with all the various options. And you can still use all the things that you're familiar with, like the SPI, FFS, and so on. So, in particular, what you will get in this thin API is actually a lot of graphics. Understandably, it's a lot of graphics-related commands. I have yet to add the accelerometer support and so on, but you also have access to external SD card and so on. And different core boards have different kind of peripherals and accessories. So you see here, if you go back to this, you see that there are a ton of built-in peripherals: speaker, microphone, capacitive touch, vibration motor. In this, hi, are you able to see me still? I just received the error message about an unstable internet connection.
Yeah, it's a little bit distorted, but it's fine by now.
Okay.
Yeah.
Maybe I can stop my actual video for now.
Mm-hmm.
Okay, so now what happens with the M5 stack is that in addition to the ESP32, it actually has a helper ATmega 328 underneath it. So in order to use all the other features, essentially the ATmega acts like an I/O expander, if you will. That's why it's necessary to start with M5 begin. Let's see, how can I look for the laser pointer? Yeah. Okay. Yeah. So
we see your mouse.
Okay. Very good. So you can in fact, so you have to initialize the M5 system by using M5 begin, and there are actually other commands, like you can individually initialize different subsystems, but in fact M5 begin will actually start all of them. And then once that is done, you can in fact use other things, like, for example, the 3 buttons on the front face are exposed as words as well. M5 button A, B, and C. That returns a false or true as to whether they're pressed. And then there are LCD sleep and wake words. Words that return the width and the height. Set the rotation of the screen, because you may use the M5 stack in different orientations. Then fill and color and so on. And the rest really should be quite self-explanatory. For the details, you won't, of course, from the source code itself, you will see here, draw line N4, N3, N2, N1. That's not very clear. But what happens is that if you go to GitHub page, all the various parameters are explained. It tends to be starting XY and ending XY, or the width and the height, and the last number is the color. So in order to facilitate drawing of color, the M5 stack uses what they call packed 565 RGB. essentially meaning that you get 5 bits for red, 6 bits for green, and 5 bits for blue. And they provide a function that will pack that into a 16-bit value. And we've exposed that here as a function. You need to use that quite a lot when you're doing, and define your own constants and so on. So that's also a parameter that tends to get used quite a lot in a lot of the functions. Like, for example, the last parameter is usually color, right? For draw line, draw rectangle, and so on. So we step into the next thing. One of the things that we needed for the project is actually also SPI. So SPI in my interface as exposed, you will need these constants that will help you. It's basically an expression of the built-in Arduino constants, and then you must specify your own slave select, of course, and set it up. So in this case, we're setting it as output, and then we're initializing it so that it defaults to high, and then we've defined here thermocouple read. Now the maximum 6675 thermocouple, it doesn't accept any input really, so you can send it anything you like, which is why in this case I actually send it 0, because all it does is it will constantly convert the value from the thermocouple and output it every time you activate the slave and run the clock. Now, you have to be aware that if you look at this, you'll think, oh, that's a bit strange. Why is he initializing SPI and beginning the transaction every time and then ending the transaction and so on? That seems a little bit wasteful, right? The reason for that is because on the M5 stack itself, it actually uses SPI for quite a number of different devices. That it uses it for the display and also the SD card. And as a result, you may have to do this, in fact, so that you don't cause a bus contention, because they may configure the SPI peripheral with different parameters. And then finally, I've created a small word over here that just performs the floating point conversion of the value according to the data sheet into Celsius. And if you need it for Fahrenheit, the data sheet has the appropriate conversions. Finally, we mentioned the relay. I haven't really gone into the relay here, but it's very much like blinking an LED. That will in my scheme of things, if we go back to this plot, you'll find that their power goes to 2 portions. The AC power goes to the heater at the bottom, and it also goes to the fan at the top. Now, what we'll want to do is that we want to keep the fan going no matter what, in order to keep the condenser cool. But what we will be doing is to turn the heater on and off as required to maintain the temperature. So because of that, in fact, it's mainly the heater that is connected to the relay, and not the condenser fan. Right. Okay. And in addition, in the project, I made use of because this will end up having to be a standalone function that we could eventually just simply turn on the machine. It's running forth underneath, and we just want to set it going. We shall make use of the blocks of the block editor and the SPI FFS to store all our functions. And so in here, in fact, later on I'll be adding it into the auto exec so that we execute we load block 0 and later on block 1 as well. And it essentially initializes the M5 system, and then it sets the default text size, defines a bunch of color constants, which I've already recorded down the resultant numbers that you get when you run M5 color, convert them into M565 RGB. And we have here, of course, the SPI and thermocouple read functions. And I've defined a few utility functions here. Now, this is where we get into the power of 4, actually, because I think if you look at the traditional development cycle for M5 stack, if you notice that they place at the front here UI flow. If I'm honest, they seem to push UI flow and MicroPython a lot, and that's because I think if you were to that already compiling ESP32Forth is quite a big endeavor, takes a while. And if you were developing an application, and embedded user interface screens require a lot of tuning, a lot of adjustment. You try the button here, you try the button there, try the button with different sizes and so on. And if you have to recompile it each and every time, you can imagine that starts to become a very time-consuming thing. And that's where running all of this in ESP32Forth really makes a big difference. You can literally try out all these functions quite easily, right? So here for draw menu, I've defined a new text size, and then I've said that so this is a smaller text so that it will define start, stop, and the quit buttons. We can define the text foreground and background colors, and then it's as simple as defining the buttons you want and the locations you need. So X and Y, width and height, the color to draw the text in, and then you define the text as a 0 null terminated strings. And that means that you can very interactively adjust the screen. We'll have a go at running some of that in a minute. Change the camera over. Okay, so that we can get into the demo part of it now. Let me just adjust it. Any questions at this point? If there are none, I'll just
go ahead.
I think Bill is muted.
Yeah. Hi, yes.
Bill, now it works. So we couldn't hear you up earlier. Jason, just proceed. I think we can ask some questions afterwards.
Let's see. Okay, I'm gonna stop sharing. Stop share, and then let's get the camera going.
My question was if after the meeting we will have to a free sample of your distillation.
Yeah, we have to figure out how to ship some to everybody. Yeah.
Yeah, great.
Okay. Yeah, that's a bit. Yeah, if you give me a moment, I'll just switch. Sorry, just give me a moment to switch my configuration around. slide. So I actually had this all set up in a different room, and then I had to move just 10 minutes before the presentation started.
Yeah, no problem.
I wanted only to say that how easy it gets with ESP32Forth, because you have the macros and you don't need to be a specialist in C language to interface to the Arduino IDE.
Yeah. Okay. So what I'm gonna do is I'm gonna start the. Okay, right. I'm going to share the. Yeah, I'm going to share this now. So we saw before that we had loaded those words into the block editor, right? And we are simply going to run and load them. Right, so as simple as that. And then if we, I'm not sure if you can see my.
Yeah, we see your screen. COM10 PuTTY output.
Screen is well.
I see the text, but I don't see the device anymore.
Okay, is Jason still there? I think he dropped out. Yeah, it looks like he's not in the list of participants, so he will probably reconnect and then continue his talk, which gives us some time to do a discussion. So I find this very exciting to have the M5 stack available, and with all the nice things that the M5 people actually do, like a terminal that you have on your hands and many exciting things. And I always thought, well, okay, it's another family, it's out of scope, and we'll stick with these things. So I'm very excited that Jason actually did the transfer of ESP32Forth. So it's now also in our reach. So that's great. And so are there any comments, questions while we're waiting for him to reconnect?
Jason is a great asset for our group because he owns this distillery where he can implement force in a professional way and on his own shoulders. Because if you are employed in a company and you try to make experiments, it's more complicated than.
Yeah, sure. Hello, Jason, welcome back.
But he's demonstrating that that force can be used in professional automation, and with these powerful devices, you have a lot of flexibility. With the Wi-Fi, you can integrate many different controllers in a company.
Exactly.
And poll everyone from a central computer and have all the data updated, how each distiller is working, or how temperature is working at some oven or some air conditioning device. If you have a greenhouse, for example, Jason has also another project for a greenhouse.
He dropped out again. Yeah, so that's all great. Go ahead.
It's also really interesting that there's a local UI on that device. I mean, that's really powerful to have, like, just, you could like have a distributed, you know, controls. You could have something in your front yard or your backyard, and like, oh, what's my schedule like, or like for irrigation or something like that. Having the UI on there is really, really nice. I like that.
I see in many groups people making a greenhouse and different soil sensors for irrigation, like you said, Richard. And they resolve this with other languages like Arduino IDE and C++, etc. And it's much more complicated, but people don't get the idea of force easily.
Yeah, the interactive testing is really awesome. And I also like the idea of being able to forget a section of words. I think that if you had a really small controller, you could have like a book of words for one particular function while you're doing like motion processing, and then you could forget that and then do like arm articulation or something like that. So I think that's a fascinating option as well.
Yes, it is. So, Jason, are you with us again?
Yes, I got disconnected twice in a row.
Yeah, well, we just continue in the vein of your talk, the capabilities of the M5 stack, and so you can just jump in and continue your talk.
Yeah, okay. So the idea really is just to show that through this very thin API, you know, we can add in a bunch of functions that live very that coexist very well in the Forth environment. So we talked about the 565 color before. So, you know, typically red is defined as 25500 M5 color. And we press enter on that packs that into a 565 16-bit value. If you've done any kind of LCD programming, you'll be quite familiar with this. So all those values are all what have been used in my block 0, and if you see here, actually defined quite a lot of different colors, and you also see that I packed them in all over the place to make my block 0 as full as possible. And going back to that, you know, we can just go and very interactively define our user interface and test it out just by typing commands directly. And you know, it's so immediate. If you've ever done embedded user interfaces before, you know, all the recompiling and download again and then find out that and then the boss comes over and he decides, oh, you know, instead of putting them all in a vertical list, can we do, you know, quad tiles or something like that? And everybody throws their arms up and goes, you know, come back tomorrow, you know. But not in this case, you know. You can try it out immediately, right? Clearing the screen is as simple as typing 0 M5 fill, right, and it will delete the whole screen, or you know, you can fill the screen with different sorts of colors very, very easily indeed. Right, so and then we can go back to black, and then we can try different fonts, right? So they have very small font sizes. These are all built in. So I think one of the things that you will experience if you try to do embedded displays is, you know, we have such an assumption that fonts will always be around, right? But that's not really the case with embedded systems. You know, usually there's no fonts, and you have to decide how you're going to represent it and store it in the ROM and so on. That usually involves, you know, taking a TrueType font and getting some utilities and generating them at different point sizes and defining a lot of things and 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 then after that, outputting a C array full of numbers, including that in your source code file and recompiling and all that. So the advantage here is that the M5 libraries actually come with a few fonts. They're not amazing, but the point being that it gets you going very, very quickly. And if you still want some specialized font, you can still do that. And let's try. We'll have to put a number. If I'm not mistaken, it should be. Right, so that's actually drawn 56 in a very, very, very small font. And let's just clear the screen, and then we'll change the font size to something much bigger. Okay. So the text size of 5, and then we'll do the same thing again. 100 at 100 and 100. We're going to draw this number. Right, so it is now a lot larger. Oh, it's been defaulted to white on, so let's just do white, black, M5 text, foreground, background. Some effort was made to make the words shorter, because if we it just seems like and Peter Forth also commented, people will get tired of typing such long words. So let's try that again. And then now you see it in pure black and white. And I think that is it seems very, very innocuous and maybe anticlimactic, but actually this is the power of Forth on ESP32 and the M5 stack and so on. M5 stack is merely an expression of one ESP32 system, but it's just this kind of interactivity for user interfaces I feel is extremely powerful, and it can get you going with a user interface in a graph in just minutes. I think we should all be focusing on Forth applications and not implementing all these basic fundamental APIs. So hopefully, this can help people get going very quickly and have very rich graphical Forth applications. And then we should be able to, we should be able to. Let me just pull up. I pre-wrote this just in case. So if we run this, what you'll see is that it should sample the temperature, and this is actually updating the temperature now. Why it's okay? You know what demos are like. Why it's reporting 50? I'm a little bit mystified, but this allows us to update the screen until I press quit here on the button. So in just a few words, we're able to read the temperature, update the screen constantly every 500 milliseconds until we press the quit button. And then after that, we stop and then we clear the screen again. And that's basically it. I'll do a follow-up next, exploring bang bang and PID control of the. I have some thought. Maybe some of you guys have some comments or advice about the the heater control, what I've seen is that so normally there's also, okay, I need to share a different screen. Yeah, so can you see this? Normally, I suppose a bigger, this would be called a reflux column, right? Reflux, because this first column here is what you would pack with, say, copper wool, and that creates a larger surface area for the, it also pulls sulfur and other compounds out of the vapor, and it tries to encourage a situation where you get greater condensation of the water vapor, and which will try to fall back down again and create a situation where it is mostly the ethanol that passes through into the condenser on this side, which has cool water pumping through it. But you know, when you see this, you see that this is why there is some interest in using this white electric appliance, right? The water distiller. Why? I mean, because you know, it's a lot of, yes, you can get used to setting this up very quickly, but it's still a lot of work. You know, you have to be close to a water source. You have to set up your water reservoir, set up the pump, set up the gas heating. It's a lot of work, you know, which is part of the reason for the interest in getting the water distiller functioning. And all in the name of creating a very, very efficient system using Forth.
Fantastic, Jason.
Thank you very much. So, are there any questions? Well, I actually have one. So, Jason, do you think that adding a multitasking support would be beneficial in your setup, so that you can run the force interpreter in the foreground and all your control programs can run in the background, so that you don't need to have a blocking
Yes.
control loop?
Yeah. Otherwise, you have a more complicated system, having states, and you know, you have to do nonlinear programming. Sort of provide 100 milliseconds to each thing and switch around. Yeah, multitasking would be beneficial there. Then you can have a very well updating display, as well as making sure. Although in this case, I suppose you know, the water and the heater, it's a large thermal mass. And in effect, you know, that's why a relay is just fine. We're probably looking at, if you turn the heater on for a minute, you know,
Sure.
you know, we're not talking about, but still, yeah, that it would be the basis of a principle of a well-written system. I haven't thought about it, if I'm honest. My direct approach would probably have been to give everything like 100 millisecond slots, I suppose.
Yeah, still this could be done. Well, my main concern is that when you run your program, the outer force interpreter is blocked. So you have to press the quit button to get control again. I think it would be much nicer to not block it, but have it available and run your program in the background, so to say.
Yeah.
So that you can still investigate and check for variables and whatever. And yeah, well, maybe that's a good topic for a future talk.
We'll definitely be trying that.
Right. So, any additional questions? Well, then, thank you very much again. I found this very inspiring and very, very good to know that we can now also use the M5 stack for our work. So that's really great. Thanks again. Our next speaker, according to our updated schedule, will be Bill Ragsdale, and he will talk about one of his two topics, and he will introduce the topic by himself, I guess. Bill, are you ready to show your presentation?
We are ready. We are engaged.
Yeah, then please go ahead. The stage is yours.
We will. All right, we are engaged.
We see it.
I'll mention that a little bit later, that I'm writing a book on Win32.Forth. So what we're going to be seeing today is, as I develop sections of the book, I write them up for my own benefit for the inclusion in the book, and I formalize them to present on an educational basis such as we have here. So the topic for today is memory allocation in Win32.Forth, and also from the ANS standard forth. So in the usual casual use of Forth, if you need memory allocation, you can do it by a number of methods. You can create, and then following that would be a dictionary memory space by allocate, by allot rather. You can declare variables, you can declare valuables, strings, and so on. But the problem is all of these are embedded in the dictionary. If you overflow the storage space, you can corrupt the dictionary, and they're special purpose, generally single function uses of memory. So if you need more, how would you need more? Well, imagine you're doing a large matrix, maybe a 500 by 500 or something of that sort. Or you're doing a database. In this case, you need extended multi-dimensional storage. Or in the most simple case, you're just going to hold the contents of a file. Imagine you're bringing in a megabyte file. And so rather than emplacing that megabyte file in the middle of the dictionary, you'd like a big block of memory allocated. So fortunately, the ANS standard provides for that. And it has 4 standard words. These require and generate parameters, and they are really the building blocks. You can use these directly for memory allocation, but they're also usable directly. The basic one is allocate. If you designate the number of bytes you wish, say 1024 bytes, execute allocate, and it will return the address of the block and a flag, and the flag indicates correct completion. The free word will do the opposite. You give it the address of your allocation, and it will return a flag saying the allocation has been correctly released. Now, it's kind of interesting and clever that the identifier for the block of memory is its address. So call it file ID, if you will, is just the address itself. So once you receive an allocation, you would store this into a value, and then every time you reference that value, you are referencing that allocation, and then it's available for storage in that area. A resize is available. In this case, if you give it the address that is presently allocated and the U value is for a new allocation, again, you will get the address of the new allocation and a completion flag. And finally, a very internal word is this word memory.alloc, and that is just a return flag value that tells you, is this function available? So if you're writing an application and you want to know, do I have available memory allocation, that flag value will tell you. In Win32.Forth, it's been simplified for the user standpoint, and the error flags are already taken care of. So in this case, you just say a number in M-ALLOC, M-Malloc, and this will give you the fixed allocation. And if not, the program will return to quit, and you basically have to restart. Release is simpler. In this case, you just give it your allocation number, and say release, and the information and the storage is released to the operating system. I'll note if you do not release the memory, it stays allocated indefinitely. And some applications used to be known for what they call memory leakage, where they would take an allocation from the operating system and never release it. And so your free memory in your computer would get smaller and smaller and smaller until you finally hit a point where the operating system will give you a warning saying you're out of memory. So you always, of course, from good housekeeping, want to release memory that you allocate. And then finally, you have the reallocate word. So those words are more application oriented, and you don't have to worry about error control yourself. So here's an example. I enter 1024 allocate. This is the ANS word, which returns the address and a flag. The next line, the -271 question throw, does the error control. The error message -271 is an ANS standard word for, I guess not ANS, it's a 132 standard word for memory allocation error. If the flag is false, execution will continue. And so that allocation number currently on the stack is passed to value, and that's assigned to a new value, memblock 1. So from now on, memblock 1 contains and will return the allocation location in memory. The word mallocs will show the allocation, and that's the table down below. So at any moment you can do you can check to see all the allocations. Now, the 1024 is circled because that's the most recent allocation that was made. And if you notice below it, there's a 9 megabit and a 1 megabit. Well, these are actually the allocations by fourth. These are the 9 megabit is the dictionary space that you have available, and the 1 megabit is low-level code. So again, we see how Forth is a good neighbor sharing the resources of Windows. This is an example of usage, very brief. In this case, remember, we have just created a block of 1024 bytes and named it text1. I take that back. In this case, we're creating a string. So we're creating a string, text1, and that string just says sample text for allocation. The next sequence is placing that into memory. So the first thing we do is we designate text1, that is the source, memory source. Memblock 1 is the destination. And then the sequence text1 count 1 plus nip, that just calculates the number of bytes to transfer. It goes into the text that we have in text1, gets the count address, and we do a C move. So that sequence moves us from the dictionary allocation into our new RAM allocation. As a verification, there's just a simple line of text there that says display the words restored, we stored, and then we go into the memory block account and type, and that will display our string. So in this case, the output will say we stored sample text at allocation. That verifies that our text has been transferred to the file. This is a little more involved. This is putting all of this into a new word to do a reallocation. So the process to reallocate says that we're going to specify the new block of being 2048 bytes. The old memory address is memblock 1 and reallocates it. Again, it returns a potential error code, -271 query throw. And if that executes properly, we transfer or to this a new address to our memblock 1. So memblock 1 now contains the 2048 allocation. And again, we do mallocs to see the allocation. On the next screen, we'll see the report. And then finally, the little report to say, did this transfer? Sure enough, here's our result. The allocation now is 2048 bytes. And in green below, we see the error message or the success message that says sample text for alloc, and it did copy over. So that shows success. And the last case is we're going to free our memory allocation. So we just say memloc1, which gives us the identifier for that allocation. We free it. We do the error check, and then again, malloc will show us that the allocation is gone. So we have, as a good neighbor, we've returned that to the operating system. Now, to kind of wrap this up, when I began to use the file access, it's a little bit more involved, and you have a kind of a three-step process. But in this case, the memory allocation was much more straightforward than I originally thought. You just designate the amount of storage you want, and you give it a name, and you have now returned that allocation. So I'm doing a lot of work on developing a matrix language, sub-language in Forth, and now I'm going to be using this directly into that application. 132 Forth has simplified the parameter passing, so it's more convenient at the user level. And finally, I've done investigations of words like catch and throw and locals as I'm adding to my book. And again, I watched the moment you have a clear understanding these become absolutely essential, neat, fun tools to use. I've mentioned the book that I'm preparing, and here is a potential cover for the book. And the reason I mentioned it here is that we've seen these new chatbots coming along that do intelligent responses. Well, there are two of them that do graphics. And so on my very first try, day 0, on this graphic chatbot, I entered a galaxy on a star field for a book cover. And this was the image I got back. A galaxy on a star field for a book cover. It gave me 4 choices, and this is the one I picked. So this is right now the working cover for the book. If we use Upwork, which is a way to find contract work, my budget guess on this would be between $100 and $500 to generate this cover art. And here on my very first try, knowing nothing, I went to a chat bot and I got a usable book cover. So the world is changing out there, folks. The external world is getting smarter and smarter. So that's competition for programmers as well as for graphic artists. And so I thank you for your rapt attention. I have limited audio at this end, so I'll be glad to take questions, but my little speaker is a little bit flaky here. So are there any questions? Good. I shall return control to mission control. Erlich, thank you. Ulrich, thank you very much.
Yeah, thanks. I think it's nice that you can use catch and throw to actually control the memory allocation and deallocation. So if you know that you need memory just in a specific block of your code, then you can encapsulate that, and even if you have errors, you will release the memory. So that's a quite nice technique. Adley.
Yeah, I see the same is coming up in the chat here. These are wrappers around Windows functions so that there's no risk of memory fragmentation here, is there? That was the question.
Yeah, how do you mean wrapper around?
Well, it asks whenever you do a malloc, you ask the operating system for the memory so that it maintains a handle, and it can juggle all of these memory blocks and do garbage collection and all these things, so that in case of working with a linked list, for example, you allocate something, you free something, you allocate something more, you free it, and you continue. And after a while, you will have lots of tiny little memory blocks that you can allocate. But so together, you might have, say, 1 megabyte, but in reality, you can only get 100K because that's the size of the biggest free block you have. memory fragmentation, a big problem under MS-DOS, for example. But if you ask the operating system for this, then I suppose now Windows has a garbage collection system that can assemble all of these fragmented blocks into one contiguous block.
But Atle, we are very good programmers in the Force community, so we don't fragment memory. We have everything here in the.
The non-fragmentation of memory is up to the operator. That is an operator function. In the approaches I would use in my matrix system is I would allocate one major block and use that for all of the expanded memory usage, rather than individual allocations. But again, that's a design figure as you go. I have only been, my sensitivity on this is that in programming works like 10 years ago, I would be getting these out of memory messages from the operating system where I was mishandling releasing memory. And what I find out now is with the clarity and the simplicity of the ANS words, keeps me out of trouble. You know, I've become a very good guest for the operating system.
Okay.
Right.
Thank you. Thanks for
Sure.
the use of Paul.
Yeah, thank you very much. So great, and we're looking forward to read drafts of your book, of course. So do you intend to make drafts available, or?
Yeah, there's the working draft is on GitHub. If you go to GitHub Ragsdale, it's called the Win32 Guide, and that is about 100 pages, and it's primarily notes that I developed over a course of about 6 or 8 years, using Win32.4 for my own benefit. And I have a book on Amazon currently as a story of a magician. It's called John Scarney More Than Magic. So if you go to Amazon, you can find my book there. And the publication method is so convenient. Once you have a PDF of a book, you put it on Amazon, and they handle printing, distribution, money, everything. That's nice. Where this book is headed, but I also intend that it will be available as a PDF. So it'll be online as a PDF. If you want hard copy, it'll probably be $25 at Amazon. So you can have electronic copy.
Great, thank you. Klaus, you have a comment, question?
Yeah, where do I find the program of today's meeting?
I sent you the link. I put it in the chat. Our next speaker will be Brad Rodriguez, and he will continue his talk on Isomax. And because many of us are interested what this actually is, he will do an in-depth introduction to it. So, Brad, are you ready?
Well, let's do a sound check. Can you hear me?
We can hear you loud and clear.
Okay, I'm going to share my screen and stop the video feed. Application window. Because we've learned on my bandwidth, doing the video and the screen share causes things to break up. Are you seeing my screen? An introduction to Isomax?
Yeah, we see it.
Okay, great. Well, thank you for inviting me here today. Late last year, when Peter and I were talking about presentations, possible subjects, I said I could do Isomax, but I would have to do it in 2 installments, or as actually 2 separate presentations. One on the history of Isomax, which we did last December, and then another which would be a description of the Isomax language itself. So that's today is the Isomax language. And as I said before, Isomax is basically a set of extensions to Forth to allow the creation and operation of state machines. And I got tripped up in December because I didn't have a dictionary definition handy of what is a state machine. So I'm going to correct that now, I hope. And frankly, I can't do any better than the Wikipedia definition of a state machine. It's concise and it's accurate. So I'll just use Wikipedia's definition. A finite state machine is an abstract machine that can be in exactly one state at any given time, and there's only a finite number of states. The change from one state to another is in response to inputs to the state machine. And that is called a transition. So you do a transition from one state to another. A finite state machine is defined by a list of its states, its initial state, and the inputs that trigger each transition. Now, that can be done just by defining all of this in a big table. You can create a table defining your state machine. But far more popular is the state diagram. And I've created this example, which is about the simplest state machine I could come up with that actually does something useful. And this is an extremely simple stoplight for a very small town, such as the one I live near. And in fact, its stoplight does go into this mode after midnight. This is a machine with 5 states, controlling a stoplight that handles north-south traffic and east-west traffic. And the default for this is the north-south light is always green and the east-west light is always red until someone pulls up to the intersection on the east-west road and needs to turn or needs to go straight for that matter. So we start with the north-south light being green and east-west being red, and as events happen or as timers expire, it advances from state to state. This is as simple as it gets. There are 5 states. Each state has only one incoming transition, one arrow pointing to that state, and each state has only one outgoing transition. And I'm sure that everyone here, given this problem, could come up with a 4th solution in fairly short order. For one thing, this idea of 1, 2, 3, 4, 5 states just connected as they are there, we also know as a loop. We're going to do a loop as a state machine. But first, this is what I came up with for a 4th solution to the problem earlier this week. The stuff on the left is your I/O words. So the flag for the sensor that there's an east or westbound vehicle waiting at the intersection is a bit at some I/O address. And the lights for north-south traffic and for east-west traffic are controlled at some other I/O address, with the understanding that there's 3 bits at each of those addresses controlling 3 lights, red, yellow, and green. And I also assume for this that there is a millisecond delay word provided with your language, and you can change. This example, it was a 10 millisecond word, so if you want to wait 5 seconds, you wait 500 times this do loop. The stoplight loop itself is an infinite loop. There's state 1, north, south, green, east, west, red, 20-second delay. Then it goes to state 2, which is begin, wait until, don't change the lights, just wait here until a vehicle appears. 3 is changing the north-south traffic to a yellow light so they can slow down. 5-second delay. Then the north-south traffic gets a red light, and finally the east-west traffic gets a green light. And then the final state is when we need to switch it back to north. The north-south is still red, the east-west gets a yellow light, and then it loops back up to the top where the north-south turns green again. That's pretty efficient, but there are questions. What if, for example, you need the processor to be doing something else while this is going on? What if the state machine is more complicated, such that we have to deal with sensors in the roadway for the north-south and the east-west and cars turning, and there are also push buttons for pedestrian traffic to cross the road? It can get complicated very quickly. But this simple example is actually a little bit more concise than the Isomax equivalent. This is the Isomax representation of that 5-state machine. Both the machines and the states are declared in advance. This is to handle the problem of forward referencing. So you define a machine, we'll call it stoplight. And by the way, I use the uppercase to distinguish machine Isomax keywords and Forth keywords, and lowercase for the names and variables that I come up with. So a machine, we will define a machine named stoplight. We will, on that machine, add 5 states, and then we get to fill in the state information. And that's what the rest of this page does. Taking a simple example of the first state, which I'm now calling NS Green 1. It's the first of the north-south green states. It sits and waits for the timer to expire. And when that condition is true, it won't change the lights because this is just the kill 20 seconds before going into the wait for traffic mode. But it will cause the next state, which is NS Green 2, to happen. And a lot of the bulk of the Isomax representation is these lovely long English keywords that will make any COBOL programmer happy, but they don't have the concise abbreviation that Forth has. So state NS Green 2 waits for the east-west vehicle to become present. Then it goes to the NS Yellow state, which the north-south traffic gets a yellow light to warn them to caution them to slow down and come to a stop. And then the remaining states are as we did before. There's the NS Yellow state, which times out the yellow signal for the yellow period for north-south, which, by the way, 5 and 20 seconds I've just pulled out of the air. I have no idea if our traffic lights actually go to that speed. Anyway, NS Yellow goes to EW Green, which means the east-west is getting green, and we're timing that. We wait for the timer. We only give the east-west traffic 20 seconds to come through, and then we give them a yellow light, give them a red light, and return to the north-south traffic. So the north-south traffic is very privileged in their ability to basically command the stoplight for most of the time. Okay, let me just click down here. Oops, hit the wrong button. This is the last bit of the Isomax representation because it doesn't actually have a timer word, but we can create a timer variable and create our own expired word. If the timer is non-zero, decrement it. If the timer is then 0, return a true flag, and that tells Isomax's state to go on to the next state. And the final 4 lines, the decimal 50,000 period, on the isopod, the default operating speed is 100 hertz, 100 times per second, which is how often it is testing the condition in the current state. So whatever the current state is gets tested 100 times a second. 0 seconds and setting the state to north, south, red are just initialization, so the machine starts up where we want it. And then finally is install stoplight. That adds the state machine we've just defined to the list of active state machines. And if Isomax wasn't already switched on, that would start Isomax. We can have multiple state machines run by one Isomax device in parallel. We also can use the Forth interpreter while this is going on, because all of this is running in the background. Actually, it's being run by a timer interrupt. So 100 times a second, this timer interrupt kicks this interrupt service routine into life. And that service routine then goes through all the Isomax states that are active and checks for transitions. So vastly more flexible. Excuse me. Oops. There we go. Isomax also supplies some nice, lovely verbose words to deal with I/O as bits on a parallel port. Well, actually, as I/O for anything, but this is bits on a port. With what they call trinaries. A trinary for input is there at the upper right. We define the name of this trinary. We give it an address, which is, again, some IO address in the memory space of the processor, a test mask, and a data mask. It's easier to think of these if you're a Forth programmer as AND and XOR. The test mask identifies which bits on the port we are wishing to investigate or wishing to examine. The data mask is an optional mask for inversion. Any one bit, you can think of this as an AND mask and an XOR mask. And when you've done the AND and the XOR, if you have any 1 bits in the result, any value that is non-zero, you return a true flag, otherwise it will return a false flag. And we also have an output trinary, which is, in this case, very, very clearly, you define the name of the output word. It has a set mask for what bits it will set. It has a clear mask for bits it will clear, an address, and a 4 output. So if you were to type NSRED in this system, it would turn the north-south red light on. I hasten to add that the trinaries are not required for use with Isomax. You don't have to define your IO this way. You can define your IO with Forth words. And likewise, you can use trinaries outside of the state machine. These are just convenient words for doing input and output in a nice, verbose, and hopefully self-documenting way. So on that note, I've used up most of my allotted time, and I'll throw it open for questions. I'll keep that there for a moment.
All right, thank you very much. So are there any questions? So Brad, you've been working with Isomax, and how would you judge doing things directly in Forth or using Isomax to implement things? And do you prefer the way that Isomax is doing it?
Hang on a second. I hope we're done with that screen, because I'm just going to switch back. Hello. There we go. There we go. I find the Forth method easier, although I wouldn't try doing a very complex multiple state machines in Forth. This takes a lot of the work away from the programmer, because it's handling what I don't want to call multitasking, but the parallel operation of multiple state machines. It's all taken care of, so that's very easy. I find the trinaries less useful. I prefer doing the trinaries, doing the IO rather, as actual Forth words. But this is being marketed to engineers that don't have much familiarity with Forth. And from what I gather, they love it, have loved it, since it's no longer available as a commercial product. And that's a difference, I think, in experience and preferences.
Sure. All right, yeah, so this gives engineers that don't have any Forth knowledge still the capability of defining things in a high-level way. So that's quite nice.
Yeah, that's exactly what Randy Dempsey was trying to achieve, is something that he could sell to engineers, not something he could sell to programmers.
I see. So Edle, you raise your hand.
Will it run on the ESP32?
Yes and no. I'm sorry to say, this could be easily ported to the ESP32. The problem is, it's not open source software. It's proprietary software. It belongs to New Micros, which was in Texas. New Micros was Randy Dempsey's company, but Randy Dempsey has passed away. He died early last year, or was it the year before that? I don't remember. Randy's passed away, which is a shame. And I know from discussions with him that his desire was always that this would be valuable intellectual property that he could use to help sell his company. He was at the end trying to sell New Micros, find an investor. He did not succeed. He passed away as the owner of the software, and actually, I'm sure it goes to Pam now as his wife. I guess I should say his widow. And I am not aware that anybody has attempted to purchase this IP, intellectual property, from the estate. As far as I know, it's dead. It can't be continued because it can't even be distributed in executable form without the permission of the estate. It, however, could be duplicated. If somebody not familiar with the Isomax, other than by the definitions of its words, if somebody not familiar with it were to try writing it from scratch, I'm sure that would work. But
Yeah,
at the
yes,
moment,
it does. It does, Brad. It's not so complicated. A task with timer interrupts, actually, you can do that. You can write it from scratch.
Yeah.
Yes.
Mhm. So is the documentation of Isomax available somewhere?
yes, it is. I have a lot of it stashed away on the Camelforth website under a separate download area. And I'll have to, let me make a note here to the side, on a pad here.
So that
Oh,
would be the basis of a clean room development.
Yes.
Hmm.
And as far as I know, that can be distributed. That was handed out freely. It was distributed on the website.
Mhm.
And what happened was when Randy got very ill, I made a point to download as much as I could from the website because I figured it was going to go away.
Mhm.
So that could be reinvented, or as you say, as a clean room re-implementation. And if anybody wants to do that, I'll be happy to send all the information I have.
Okay. Yeah, well, it's actually worth looking at the documentation, and so we can, as a group, can decide if we want to set up a project doing so. And that would be, yeah, would be nice. Maybe something that we could discuss earlier, later on, or maybe next month if everyone had the chance to look at the documentation. And thank you very much for your talk and introducing us to the ideas.
Oh, thank you for having me. Oh, go ahead.
Amazing, Brad. Thank you so much.
Okay.
Thank you.
Are there any additional questions? Well, then I had to check if we have Julian Skidmore in the list of participants, but I don't see him.
I think he's not there.
He's not there, so he would be the next to talk, but I saw Christian, and that's great. So I would ask you, Christian, to talk about Zeptoforth and the first steps that you can do with it, and I will certainly learn the features of Zeptoforth, but because I heard the name, but I'm not involved in what it can do. So Christian can tell us. Christian, are you ready to talk about that?
Yes, I'm ready.
Okay, then I would say please share your screen, and then we're excited to hear what you can report.
Okay, so let's see how I can share the proper screen. Are you seeing a screen now?
Not yet. It's starting. Yeah, now we see it. Some Word document, Zeptoforth on the MakerPi Pico.
So what are we going to do today? Just cover Zeptoforth very quickly. We'll install it. We'll introduce the Zeptoforth implementation, and we will demonstrate the basic use of Zeptoforth. I'll do this on a Cytron MakerPi Pico board. I'm using a Windows 10 PC and a web browser-based terminal emulator and editor that comes with Zeptoforth. That's a very nice feature that I liked. Who am I? A bit of a Forth freak, but essentially I was trained as an electronic technician. I don't have much knowledge of computer science. I always had computers since they appeared. I had a ZX81, an Apple II, and since then all kind of PCs. And I got charmed by the MCUs when they appeared. This is the magazine that convinced me about Forth in 1980, in August 1980. I still have a copy somewhere in the box. Now, my first Fort friends were really a lot less than what we're going to look at. It was Flash Fort and IM Fort on Uno and Nano. It was also eFort on the STM8, Funny Fort on the Node MCU ESP8286, Micros Stellaris on the STM32F103, which is known more likely as Blue Pill. And Micros also runs on the RP2040. All these that I just named are single core. And then suddenly something appeared, multi-core. I tried that with Tachyon on the C3 Propeller 1 baseboard. And it's also possible with Zeptoforth on the RP2040. So here are all my friends. So the Nano, the Uno, the funny SM8 family running on the thermostat board, the 8266, the Blue Pill, the C3 Propeller 1 board, and then we can't forget the good old ESP32 and a Wheel RP2040 that is RP2040 base and also has Wi-Fi and somehow also runs the Zeptoforth. So this one here is the one we're gonna run Zeptoforth on. It's my new friend. We see it a bit better here. So let's see what else we can say about this guy. Well, why did I choose Zeptoforth? Well, it appears to be very complete. It supports all kinds of computer science concepts that I never understood. So I could learn something from it. It's available at a low cost on the RP2040. It has programmable I/O processors. I don't know exactly what they are, but they appear to be quite useful. It's the only Zeptoforth. Zeptoforth is the only board that I saw that provides multi-processing, except for the ESP32 that does it through an RTOS. The installation is simple. The documentation is excellent. It's still evolving very fast, and it's well supported by Travis Beeman. It provides that very nice little web browser-based development environment that includes terminal emulator and editor and allows loading files from your PC. It's mature and stable. So we just basically covered my reason. What does it do? Why it runs on much more than RP2044. It runs also on many STM boards, 32-bit STM boards, so they're all named here. Included features. Why it has most of the normal MCU concepts, like it's got GPIOs, SPI, I2C, PWM, RTC. It's getting a bit fancier here when it supports SDHC, SDXC, FAT32. It's capable of quad SPI flash storage. So it appears to have evolved a bit. So it's got programmable input-output support. That was the big question mark for me. I said, I have to figure out what I can do with these things. Computer science. There, I'm totally lost. But all those words always puzzled me. Semaphore, lock, channels, streams. Action scheduler, multi-core support. That one I know. Lambda, totally puzzled. Closures, totally puzzled. Object orientation, my definition is not clear yet. Exception vector, maps, heap, memory pool, task pool, action pool, all kind of concepts I never saw covered in any fort before. Development tools, well, I guess it covers all the other fort did provide some form of development tool, but this one has a very nice web browser based terminal emulator editor. Okay, so the material you already know, I'll do it on a MakerPy Pico. So, and the web browser, oh boy, that's a nice one here. We'll talk about it later. If you want to understand what we're doing, I think it's a good idea to know what the RP2040 is, so you could get the RP2040 datasheet. Like now, let's install this. We can't do much without the installation, eh? So you have to get a zip file. You get it from here. Let's see if you might not see what's happening because it will be happening in my web browser. Okay, maybe I could drag this over for you to see it. Okay, so are you seeing it now?
Yes.
My web browser. You need to download this one here because the zip does not include the binary file. You don't, if you're very good with programming, you probably know how to build something and you could do it with the zip, but this one will download. So let's see. So it's coming in. And it's probably now, let me see. No, it's taking more time than I expected, but it should be now in my web browser. Okay, so it's now in here, in my download. I will unzip it into a folder. Okay, let's open it. Guess what? It's a double zip, so we have to unzip again. And now we really have everything. That's the latest version that Travis just put online about 2 days ago. And the binaries are in here. And with the RP2040, you use a file that is called UF2, something like this. We're gonna try with the full one, okay? It's probably very big and has a lot more features than we really need for the demonstration, but that's the one we're gonna use. Okay, let me make this a bit smaller so that we could do and let me bring another. Oops, where do I get a second browser? Can't even get rid of this one. Well, the whole idea here is really to simply drag this file into another browser that would have the USB drive on the RP2040 active. And by just dropping it into that drive, it would install the UF2 file and Zeptoforth. So I can't find a way to open the second browser, so I'll just forget about this. So, welcome. Oops, I dragged the wrong one. We'll get back to this. So basically, we covered the part where we get the zip, we unzip it, and the rest of the, so you decompress it, and you open the file browser and locate this. So we did it as well. Enter the RP2040 bootload mode. I wonder if I could show it to you how you do it. Let me see if I could get a camera in there. Camera, where are you? Here. Okay. Okay. So the whole idea is basically, we'll assume here that the UF2 file has been loaded, but wow, it's not yet loaded. So the whole idea is to disconnect your, you start with a board that is not powered up. You depress the, how do they call it? Boot select button, and you power up. And the RPI, RP2 drive becomes active. And that's where you just drag the UF2 file onto that drive. So that would be essentially the bootloading process, or it's the new form of loader. So I think you've seen how simple it is to install it. So you open it, you drag and drop, and that's it, it's there. Accessing it is a bit harder because the RP2040 does not have a chip that is dedicated to a USB to serial port. It's got a USB peripheral within the RP2040, but it has to have a program to make it work. And the actual UF2 file does not allow using that for a serial port adapter, but it does allow using it as a USB drive for loading the UF2 file. So we have to connect a USB TTL adapter. Here's the one that I use. It's a YP something, YP2. And this little jumper here is important because it allows you to provide the proper voltage on the receive and transmit pins. The jumper, if it's up, it's 5 volt. If it's down, it's 3.3 volt. I'm just mentioning this because too many people just drive a 3.3 volt MCU with 5 volt RX and TX. The connection, very simple. It goes on, you need 3 pins, and you need to cross TX and RX. And that's about it. Maybe I have a picture of where it connects on the board. Let me see. Yep. The first 3 pins here just to the left of the one. If you're facing the USB connector, to the right of the USB connector. So not very complicated. Then you see the lights are on. It's nice that board has LEDs on every pin, so you know when something is connected and works. So let's go back where we were. Now that we got this connected to a serial port, we're gonna start the Zepto JS. Okay, let's go. It started in my browser. I'll bring back the browser on the other side. And here it is. There's something I don't like here. How do I switch screen? Is it done?
Well, if you have multiple screens, then you have to stop
I have
sharing
to
and then reshare, and then you can select the screen that you want to share.
Well, we'll try to do it on the other screen because I can find the button to do it. It's just that we don't see the whole thing. We don't. Okay. So we have a terminal pane here, and we have an editor pane there. So it's, as it says at the top. And we have a small one-line command entry section. Let's see if it's working. But oh, I forgot something. Let's connect. Now that looks better. Did we get a response? No. That doesn't look too good. Why do I get no response? Let's try disconnect and reconnect.
What's the little baby?
COM5, everything is connected, connection. Well, at least we can see here that it came back and said that it was Zeptoforth.
Just as an example, hit reboot. There's a reboot button. Press it.
Reboot?
Reboot. It's at the bottom.
Yeah, I restarted the RP2040. Oh, I got an OK. And it says it gives me the version and everything. So maybe it's gonna work. I got the second OK, that's good. How many words do we have in there? Way too much. I can figure out how to use them all. But I'll show you. It gives you an idea how fast it can show things when we see all those words. Okay, what else can we do with this? I'm gonna bring my word back to the other side so I can figure out where I am. Okay. So basically this interface, I already said, provides an edit pane, a terminal pane, a data entry field, and various buttons to do funny things that are very nice to have. At the very bottom here, you got send file, and even has a help button that shows you everything that those buttons can do. I found that's very useful. Now, the two interesting ones, send and send file. Send will send whatever is in the editor. Send file will go on your PC, allow you to browse to find a file, select it, and load it. into the into the RP2040. That's very nice. By the way, you can reboot if you want. I just did, and it will come back just by this button. Attention, I didn't figure out what it is yet. Clear will clear whichever. See now, but they're both empty. So you could, the content that was in the terminal or in the editor can be saved on your disk. You can, a pen file was a bit, I couldn't figure out first what it did, but when I read the help button, it told me it allows you to get a file in there. So if you click on it, you find something on your PC that you want to load. Like, okay, let's try this one. And now I've got a Blinky in my editor that I could simply execute if I want. But first, before we do this, we'll just do some experimentation with the simplest thing, the simple data entry field here. So, okay, you enter 1, 2, 3, .s, which will print the stack. And what do we get? So it entered 1, 2, 3. I told it to show the stack, and it shows the stack. So for simple things, you can do it there. Normally, it's used only to start the program that you loaded from there. Now, load the program directly from your PC disk. Well, let's load one directly from the PC disk. You use send file, and I probably have, oh, we're gonna use the same one, the Blinky. Blinky, where are you? Okay. So it did load the Blinky. Does it blink? No, I'm gonna have to bring back my camera. Camera, where are you? Browser. What? Okay, maybe if I make this. Well, my camera is hidden somewhere under there. Ah, here it is. You see the Blinky? It works. So I'm glad. Now, how do I get back to my screen where? Okay, I need to get back to my browser, my web browser base. It's somewhere in here. No. Yes. And the last one that we'll do is load the fancy one. Okay, let's try to load from. Well, first of all, we'll reset to make sure we start with something new. And we'll just Sorry. It's not what I wanted to do. There's a nice one that uses the PIO on the MakerPod. No. Load. Where are you? Send.
Try reloading it again.
Sorry?
What happened there was that the key, that Blinky ate the first character of what you're uploading.
Save, clear, attention, reboot.
Just try uploading the same file again and it should work.
Well, we'll just do it directly. I can't find a way to load it. See, my buttons have all been changed in location by changing screen. No, not this one. So I just loaded the fancy little program that will do a LED flashing with PWM from 0 duty cycle to 100% and keeps on going. How do we start it? With this name here? Now, camera, so you could see it. So the same LED that was flashing, but this time it goes from nothing to full brightness. So that's essentially how simple it is to use Zeptoforth. And my main reason is exploring the PIOs and understanding the computer concepts. Zeptoforth also has a lot of, let me bring this back here. It has other versions that are not as heavy as this one. So if you don't need all the fancy stuff that is more computer science oriented, you can use smaller UF2s that provide less functionality. And Travis is still working hard to make this Zeptoforth a real nice fork. He got it running on the XIAO RP2040, and it even runs on the WIO RP2040. I have a version of this, and I loaded it into there, and it worked. But he's now working with the WIO RP2040 to make it work with Wi-Fi, and integrated within that WIO 2040 is a Wi-Fi ESP8285, and he still has to complete the driver for this. It's using a funny way to access the 8285 from the RP2040. It's using the SPI to provide some 80 commands that normally are sent through a serial port. So it's a bit tricky to do, but I think Travis will get it done.
Well,
what did I really like about this one? It proved to me that Forth is adapting to the current MCUs and computer science technology. Forth can evolve And that's the end of my presentation.
Thank you very much.
One thing about the Wheel RP2040, I now have it talking to the 8285.
Ah,
Yes.
Excellent presentation,
Mhm.
Christian.
Yeah, thank you very much.
We love to see.
So if you have any questions to Christian or Travis, he just is also there. If you have any questions, then go ahead, Peter.
Yes, Christian, that was an amazing presentation. I thank you very much in the name of all the Force 2020 group. And we hope other people get inspired by Christian to show us in demo mode. So basically everyone can start a session with us on the group and show what you do with Force. There is nothing complicated. We don't expect the professional ones, but the real users of Force. And another thing I want to ask very shortly to Travis, if there is a possibility to get the USB of the Pico to be the installer, like we have in MicroPython and in other languages, if that is a goal, a future goal for Zeptoforth.
Well, about that, can you hear me?
Yes.
USB is a future goal, but do not be waiting for it because implementing USB serial is not trivial. And but I know there's been a lot of demand for it, so I'll get to it sometime. I'll have to.
Okay.
the way
Yeah.
I know you, Travis,
Ask is
sometimes it's quite short.
Working on the wheel.
Very good, very good.
Mhm.
And Pablo and Richard, any one of you, please go ahead. Oh, Pablo first.
Christian, I have a question for you.
Yes.
You say in the presentation you come addicted to Ford. You know why?
What was the question again?
Why you say you are addicted to Ford?
Because
why you
once
think you are addicted to Ford? Where is the?
Because I can't understand why since 1980 it never came out of my mind. Anytime I wanted to do some programming, I always wanted to go back to Forth. Well, the only other programming languages that I knew were BASIC on the Apple II and ZX81. And I like the interactive part of BASIC. And at the time in the 80s, C was not something that was available to everybody. And it stayed in my mind that there was a nice interactive programming language that was easy to learn, that was named Forth. I didn't really use it much, a little bit on the Apple II with something called Graphort. But it was way too complex and way too much to learn for a beginner. But when the MCUs came on and appeared in the late 90s, FlashFort appeared with NetMega 328. And that was very much simpler. It was an 8-bit CPU with just a few peripherals. It was something that I could use. And I grew up from the 8-bit, never did anything in the 16-bit MCUs, and started using after that the 32 bits with the blue pill. So I guess I stuck with Forth all the way as the MCUs were evolving. I wanted to work with something simple. And the Fort was simple, and the MCUs were quite simple. I didn't have to master the underlying OS to be able to do something like I would have to do on a PC.
So Richard raised his hand. So you have a question.
Yes, I was wondering if Zeptoforth in the environment, the browser-based environment, was tested on a Chromebook. A lot of individuals out there can't afford a full PC, and I know that a lot of schools are supporting the Chromebook. So it looks like this, you could actually have the full development environment solely from a Chromebook. That would be kind of awesome.
I think it will work on anything that runs a web browser.
I know. It does not work with Firefox.
So what's your answer, Travis?
My answer is that, well, because Chromebooks run the Chrome family of browser, I know it works with PC Chrome and Chromium perfectly well. That's what I always use it with myself. I know it does not work on mobile Chrome.
Yeah, this would be an Android-based, probably an Android-based.
Well, that's the thing is that if it's using the Android-based Chrome browser, then it will not work. But if it uses something more like the PC-based Chrome browser, it likely will work. And then there's also the issue of flashing the file system, because I've simply never flashed a RP2040 from a Chromebook. So that's something that I can't promise that it'll work at this point. It'd be very nice if it did.
Yeah, but it would be just easy to try it out. So
exactly.
if you're curious, I can pick up my Chromebook and I can run the test.
No problem, Klaus. The next speaker, when we come back from the coffee,
it's me, right?
It's Klaus. I can present you.
Should I share my screen?
Yes, please go ahead, Klaus.
Here we go. So it's about poor man's case, whatever that is. How do I? Okay. So I came up with a very simple example to show you my simplified case statement. A simple dump terminal using key and emit. It defines terminal, gets the key, looks whether this was escape, and if so, it exits the loop. And then it looks for backspace, carriage return, or line feed. And if it is none of those, it just emits the case. And then it starts over again, right? I would still consider this readable code, but unfortunately, it requires a set of case compilers that are usually not part of a small force system. So, and I was confronted with this at some point in history. I didn't like the case of end case thing because there was too much compiler fiddling around, and especially the disadvantage is if you go here, then the off always has to compile a jump to the end of, and then it goes on and it has to compile to this location. This has to compile to this location. I didn't like that. I didn't like that. So what I came up with is completely different. It uses, instead of using these jumps here, these forward jumps here and there, I just use exits at the end of the cases. And so I separate the word terminal in two parts. It's the terminal proper, which is the endless loop, except the case, the escape. And then I call decode key, and decode key kind of does all the cases: backspace, carriage return, line feed. And so I have the word case question mark, and then it just is just an if. And with a backspace, I do a backspace, emit, a space, and another backspace, emit. So with the first thing, I go back, then I erase the last character, and then I go back again. And then I do an exit and fall out of the loop, get another key, and this is how this goes on. So this is readable code as well. And it uses a return stack, and we just need one new word, which is case, instead of a whole set of case compilers. And this is the magic. Case question mark is very simple. I have two numbers on the stack. This is the key, so to speak, and this is the key number, like backspace, line feed, and so on, the constant. And depending on whether they are the same or not, if they are the same, I just return a true flag. If they are not the same, I return the original number of the key that was pressed last and a false flag. And so it's over equals dup if nip then. Period. That's all. And this, I mean, I pretty much doubt yet you can get simpler to use this kind of programming situation. And I never felt the need for any other case construct, and I have been living with this for the past 15 to 20, oh no, more than 20 years now. And yeah, it never for some reason caught on in the community. Instead, people invested thinking on the case of and case compiling functions. Questions?
Amazing. This is very, very nice, Klaus.
My question, can't you just say dup equals and drop after if? Wouldn't this be easier?
Wait a second. I have to go to the next. You mean I'd say what?
Oh, without defining case question, just use phrases. Say number dup number backspace equals if drop.
Yeah, right. That's an alternative. But I always thought, well, the word case question mark makes kind of clear what happens there.
Yeah, that's right. Okay.
And plus, it's useful for other situations like here. I also have a query exit always present, so that becomes very simple.
Right. Thank you.
More questions? That doesn't seem the case.
Well, what I must say is that this is a very elegant way of doing this that I hadn't thought of before.
A very what?
Elegant.
Elegant. Okay, thank you.
Like, I in Zeptoforth have a whole big case construct functionality, which when combined with local variable scoping and stuff like that is a big complex mess. Whereas this greatly simplifies the whole matter such that one does not need to worry about compiling lots of jumps in and all that kind of stuff.
Yeah, the whole trick here is use a return stack. Don't be afraid to use a return stack to do meaningful things.
Well, I don't think you are using the return stack, though. When I saw your code there.
Yeah, because I do a call, and that means I use a return stack, and I can get out of what I called by just doing exit. That's the whole mystery.
Oh, that's
of
what you
this
mean.
way.
Okay.
And there are more cases like that, that if you use the return stack for what you want to do, then things also in other situations can become simpler.
I apologize. I have a newbie question. What's the difference between question mark exit and exit?
Oh, question mark exit is just if exit then.
Okay. Thank you.
Note that to define question mark exit, one has to go and define it as if R drop. Then.
Oh, yes, right, you are. No, R from and then to R semicolon. Yes. Or nee, it's not so simple. So if I write here if exit then, that would be true. If I define exit in high level, it's more complex, because then you call query exit, and that is not the point where you want to return. So it must be an R if R from R drop to R then. So you throw away the second item on the return stack.
Yeah.
So these were my quick 15 minutes. Thank you.